Hey guys, welcome to your first big exercise. This exercise called airplane is going to get bigger and bigger and gonna hopefully help you learn every aspect that you'll need in the future. So, a couple things before we get started. Some of the feedbacks I was getting, it was a lot of people looking up online to figure out what this exercise is, or they would just say, go online, Google airplane assignment or airplane project or something, and you're getting someone else's thing is not going to help you, especially since no one else has the same thing as us. You'll notice as the exercise will develop, it'll even go more and more far from anything else you'll see. If you always rely on finding your exercises online, well, you're gonna fail when it comes down to the exams or projects. So be careful with that. Second thing, going online to search is still fine. However, you shouldn't search for the project or the exercise. You should search for things you want to do. So, okay, I have an airplane and I want to change the value of the altitude. What should I do? You know? Or I need to write to the screen. I need to slowly change the values, etc. Whatever you want to do, you look for that. Not someone to do your whole project, but to figure out how to do a specific task or tool you need to utilize. Okay, so putting that aside, I'm telling you, don't do Google too much. Try it your best and then come talk to me and I'll help you out. That's for sure. That's my job. Good luck with that. Let's come to our airplane and discuss it and see what we can do. The first thing I like to always do is analyze what's demanded of me, and we go step by step with that. So, we're building a flight simulator. So, we're trying to replicate a real airplane as if you were controlling an airplane from somewhere. We'll have to simulate the takeoff, the flight, the landing of the airplane. You should offer the user 6 options. So, these 6 options are for the user to control your airplane, right? So we have a couple of these. I'm going to go ahead and, oops, wrong button. We're going to just go ahead. Here's the starter code that was given to you, and we'll discuss that in a second, but let's go ahead and just make a Java class and call it airplane. I'm not going to code yet. First thing first is always to analyze, understand what's going on. So the first couple things, actually, we don't need to write it here, is we need to be able to give the user these 6 options, right? And it's written that. Okay, let's go to the next step. Where is my thing? So these 6 options, we're going to deal with it. Now, other than that, we're saying if it reaches 10,000 feet, we got to let the user know we're in the danger. So that if the plane reaches 12,000, well, the plane will explode, right? And will display some sort of message. If the altitude returns to 0, well, the airplane lands. So from this 3-4 lines, we've noticed a couple things. Let me just write that down here. So the first thing is we have some danger zone. From 10,000 to 12,000, well, let's say 10,000 to 11.9, this is warning. At 12K, explode. At 0, the altitude 0, we're landed. We're on the ground. That's 0. Let's go back and analyze further, see what else we need to build. So let's scroll down here. The main class contains main method, which creates an airplane and provides a user interface for the user to be able to control the plane and application. Now, when I give you something, I don't expect you to go and change everything and do something completely different. This tells me a couple things. One, you can't follow my orders, which is bad, because if a boss tells you to do it this way and you go and do it a different way, well, you better have explained it to him beforehand. Otherwise, the only thing he could do is fire you. Second, if you can't follow instructions, what's the purpose? If a client tells you this and you go a different direction, it's bad again. right? So if you're given something, follow the instructions. So actually the second thing would be, if you did something completely different, again, I'm thinking here that you went online and got something that's not my thing. You went and got something that's completely different, right? So you got to be careful with this. Follow the instructions, read them, take notes. So these are the user controls, and we just saw it. The user controls are here, and we're going to do the cases in a second. I'm going to come back to this. I cannot switch things. Now, the airplane class contains the fields and methods that define our airplane's state and behavior. Ensure that the logic is correct and the flow between airplane states makes sense. For example, if the engine is stopped, you cannot take off or change altitude, etc. What are these states that we have? Well, if you look at these options, we could see a couple of these states. Right? From option 1, we notice there's a motor. The motor could be on or off. Well, by logic, we know that if the motor is off, you can't really fly in the sky, right? So we need the motor on for us to be able to do the next thing. To take off, well, we need the motor to be on. Actually, let's go ahead and make this a bit more interesting. Let's go ahead and erase this. Actually, 1 second. Just gonna bring this a little bit higher so I get more screen space. Okay. So we have a motor. Now we have the choice of it being off. So let's say off. Well, if it's off, nothing can happen. So this is blank. So if the motor is off, we can't do more. However, if the motor is on, well, now we have a choice. We could take off. Well, let's say we did take off. Okay. Let's say this was true. And this is also a true or false. Motor is on, it would be true. Motor is off, it would be false. So if the takeoff is true, can I turn off the motor in the sky? Are you going to create an accident? We don't want the airplane to stop in the sky. It has to land before it turns off the motor. So this takeoff is the same as talking about, are we landed? So maybe I'll change the word here and we'll change it to a state, which would be, am I grounded or not? Am I landed or not? If I'm landed, true, well, then we could do the motor off. Motor off. Right? We're not talking about takeoff yet. If I'm not landed, so let's say false, well, this is the moment we're talking about we're in the air. So the moment we're in the air, so now we're inside the air, we have to think about these conditions we said. What altitude we are. What are we doing? You'll notice that I messaged you guys and said, the moment you take off, just increase it by 1,000. Okay, and every time you increase or decrease, just go up by 1,000 or down by 1,000. Now, can you increase altitude or decrease altitude if you're grounded? If you're on the ground, can you decrease? No, you're not going to go and dig a hole. You're in an airplane. Can you increase? Not unless you did the takeoff maneuver, right? This is why we have a takeoff, and this is why we have increase and decrease. So for us to be able to increase or decrease, again, landed has to be false. We're in the air, and from here we can increase or decrease. And the increase and decrease happen to have their own logic too. If we keep increasing and we reach 10,000, this is the moment to give him a warning. If we ever reach 12,000, this is the moment to explode our airplane. Now, while we're at it, I've noticed from the assignments given back, most of you, when you explode, you exit the application. You shouldn't do more than what you're asked to do. If you do something completely different, you need to confirm with your client, and that would be me, your teacher. So in this case, if it explodes, we'll do nothing, but we'll give them feedback, and we'll give feedback in every moment. Now, if we're decreasing, we got to remember that when the altitude is back to 0, what does that mean? It means we are landed. We're back to being landed on the ground. And that's true. Right? So if altitude is 0, altitude, I know my hand drawings are horrible. I'm doing this as best as I can. We're going back to landed. And this is pretty much it, right? And we got to put some variables to keep track what is going on. Is the motor off or is it on? Are we landed? What altitude are we at? Did the airplane explode? Etc. etc. Okay? Try not to do anything extra than what you're supposed to do, unless you go and ask and you make it happen. Okay. I hope this makes sense. Keep this in mind. I'm going to erase it because my page is a bit full, but this is pretty much what we're going to do. So come back to this location or take a screenshot, look at it while I'm coding everything, and you're going to see it's going to make some sense. And again, you do it the best way it makes sense to you. So let's going back here. So the first thing we need to do is finish off our thing. Notice that we have an airplane, but the code inside is nothing in there. And over here, we have an airplane start, kind of giving you an idea that when the motor gets started, we call this method, this action. So the first thing we need to always do is figure out what are our attributes. Sometimes figuring out those attributes could come later. It's okay. But these are our attributes, and after that, we need to figure out what are the methods, or in this case, the actions that our airplane can do. And remember, it has to be specific to the airplane. One of the actions I saw was exit. What does exit mean to the airplane? Are we exiting the airplane? It doesn't make sense for this action to be part of this object called airplane. Okay, so this exit is a bit misleading. Okay, so let's start this out. So the first thing we said, we needed to have we needed to keep track. Actually, let me do this. It's gonna be faster. We needed to keep track of a couple things. Well, how do we know if we're at what altitude? So we need to have a private integer, and we're gonna call it altitude, right? And if you want, you can initialize it here. We always start at 0. We're always on the ground. Or you can initialize it inside your constructor. Now, what else do we know that we need to have as variables? Well, the first part here, we need to know if the motor is on or off. Well, that's two values it could have, on or off, which is basically true or false. So make it something that makes sense when you say true or false. So again, private boolean is motor on. Notice I'm asking if it's on, because that way it would be true. The word, the variable would mean everything. Is the motor on? Yes or no? Right? So at the beginning, it's obviously going to be off, right? We get into the airplane is not already started. The pilot has to start it. So again, I'm initializing it to false. What else do we have here? After the motor is on, we check if we're landed or not. Now we could do this in a couple of ways. One way is to just check the altitude. If the altitude is 0, we're landed. But how do we know if we're in the air? Well, when the altitude is 1,000, we're in the air. We could do that. We could also write another boolean that said is grounded. And this one, we're going to set it to true at the beginning because we're on the ground, right? So this is up to you, because we could also use altitude. So if you don't want to have a lot of variables, it's up to you. But this is a bit more English when it comes down to reading your code. So if you do if as an example, well, I'm going to show you an example soon, okay? We'll come back to that in a second. So we got is motor on, is grounded. What else do we need? Now that we're in the air, how do we know in the air? Well, is grounded is going to be false. So we're in the air, or altitude is going to be 1,000. We're in the air. In those cases, we increase, decrease. We're going to increase the altitude. And the moment it comes back to 0, we're going to make is grounded to true, and we go back to our thing. The moment it reaches 10,000, 11,000, our altitude, we're going to give a little warning. And the moment it reaches 12,000, we're going to make the airplane exploded. So another thing we need to keep track is the airplane is exploded. Now, some of you, well, one or two, made it that when the altitude is -1, they considered that as exploded and they moved on, which is a great way of doing this. However, it's again not as readable as doing another variable that just says exploded, is exploded, or something. I like to say is because it's kind of saying the state it is, right? So is exploded equals to false again. So we're going to start as we're a good airplane, right? And I think this is good enough. We could have more or less variables that state, depending on how we code. It's up to us to determine those, right? So let's go ahead and erase that part. Actually, we could keep it. This is pretty good. So let's start off with our initial attribute here is the start. And we could rename this if we want to. This was just a sample to get us going. So in this case, we need to have access to the start from here. And again, these access modifiers are important. Actually, before we move forward, a lot of you left these access modifiers to the default, which was package private. This basically means that this airplane that I created here, I have total control over those variables. Notice this, I have access to altitude. What if I go ahead and change the altitude to this value? There's no issues with this because you made it package private. So again, remember from our lecture videos, we're going to only utilize private for now or public. Package private and protected will be for later. So anyway, the first one, normally you would say, well, we're going to make a constructor. Well, we're not doing anything fancy with our constructor. We already have our initial values. So what we're going to do is actually get these commands going. So start or engine start. So this has to be accessible outside of this class. So we're going to make it public. And we need to return something. This is up to you. I've seen some of you return booleans to say if the action was correct, or integers to represent a state. In this moment, I don't think there's a need for it. The only thing we need to do is give feedback to the user at every step. So in this case, we could call it start, or we could call it, I feel like start engine sounds better. It says basically what it's going to do. It's going to start the engine. Do we need any parameters? No, we're self-sufficient. So how can we start the engine? Well, it's pretty simple. We make is motor to true, and that's the engine. The engine has started, right? But this is not good enough. We need to let the user know that the engine has started. So we write something, airplane engine started. Or let's make this a bit more engine started. A bit more fancy, right? So now the airplane, the engine has been started. What would happen? Well, we'll come back to that. So let's just go ahead and first of all, we're going to rename this to start engine. We're done with that. Case 2. We'll come back to our start engine. We're not done. So in the case 2, we need to take off. Okay. So public void takeoff. Again, think about what we need to return when this method is called. In this case, nothing. We're changing the state of the airplane. And what parameters it requires for it to take off. Nothing. It's because it's part of the airplane. So for us to take off, we need to make sure the engine is on. So if is motor on, this is a Boolean. Remember, our if statement requires a Boolean value. It doesn't require a question. So we could just leave it at that, or some people did equal true, and this is fine as well. So if is motor on, then what do we want to do? Well, we want to we want to take off. So we want to make our is grounded to false, right? We're not on the ground anymore. And we want to increase our altitude to 1000, right? Directly, if we were on the ground, we know that we're going up, so we're going 1000 directly. Now, something I don't like, but we're going to come and change this a little bit later, is putting these values 1000 inside the code. I'm going to come back to this a bit later. So we're going to come back to do 1K values, okay? I'm going to explain it then because we need a few more for it to make sense to you rather than me explaining like this. So is grounded is false, altitude is 1000. We're taking off, so we need to give some feedback. Airplane taking off. And we're going to also give an extra feedback where it says, oops, give me 1 second. There we go. Airplane, let's say altitude 1000. And actually this part, we could make it a bit cleaner saying altitude directly, right? And even better, we could always run our application. So let's just go ahead and say airplane, take off, and we got another break, and let's run it. One step at a time, right? So we got our little application here. The other buttons won't work. So if I do 3, nothing happens. We come back to this. If I say take off, no feedback's coming in because the motor is not started. So this is one of the mistakes I did. I have to go and fix that. But if I do start motor, airplane engine started. And now if I do take off, airplane taking off, airplane altitude 1000. Cool. So we're giving feedback every state. Some of you was keeping track of the airplane states and altitude at every point. That's perfectly fine until the feedback's given. Feedback is important because if the user doesn't understand what's going on, well, they're going to keep on pressing buttons to the point where they're going to quit and go to the next application. So what would happen if the motor is not on? In this case, the motor is not on. We need to let the user know. We could say errors or whatever, airplane, some sort of message that makes sense. Motor needs to be on, or let's say motor engine sounds better. Engine needs to be turned on. And we could even say airplane error. Okay. And I'm going to keep the same wording as start engine. So let's go ahead and refactor, rename to is engine on. Sounds better if I keep the same words everywhere, right? So engine needs to be turned on. Maybe I'll go ahead and change this word to engine. And I'll change it in the next exercise. All right. So where were we at? We could actually bring those out. So if the engine is on, we could fly. If not, we'll let him know. And again, we could run it. I'm not going to run it every time. Otherwise, it's going to be hours and hours of me doing this. So we're going to do takeoff, airplane error, start the engine, take off. Yeah. Easy stuff. Next step. So if the engine is on and we fly, we could increase or decrease. Let's do those. Or actually, we could even follow this up. Oh, the next one is stop engine. Okay. Let's put that right after our start. Stop engine. And again, remember, we could come back to our previous methods at any time and change them, do things to it. So in this case, is engine on, we're going to set it to false and system and give back a feedback. Airplane engine stopped. Now the only problem is what would happen. Actually, let me go ahead and put that case. My mind goes everywhere. Stop engine. Now what would happen when our application Doop, doop, doop. What happens if I keep on pressing 1? Right? It's good that we're saying engine started, but at some point we got to tell the user, hey, you know what? The engine is already started. You don't need to keep on doing that. Or think about it as a car. When the engine is already on and you turn it again, you're kind of doing nothing, right? You're probably even damaging the vehicle. So maybe one thing we could do is to say if, oops, I got caps lock on. If is engine on. So I'm saying if not, the engine is on, or you could also say if is engine on equal to false. Okay, either or works. I'm a bit more familiar with this. It's more readable to me. In the case where the engine is not on, I'm going to turn it on. Else, I'm going to let them know airplane, how did I do the other one? Airplane error. Yeah. Engine already on. And it's the same thing when we're turning off. There's no point of turning off something that's not on. So in this case, is engine on? If it is, I will turn it off. Else, again, let's go ahead and put that. Engine is already cool. And we keep on going. The next part, public. I can't. When I do videotapes, it's really hard for me to spell anything correctly. So we're increasing altitude. Some people wrote increase, some people wrote I. The more your method name makes sense, the better your code is. 1 second reading is much better than trying to figure out what's going on. So we're going to say increase altitude. We don't need to give it any value because we're increasing by 1,000. So we don't need to give any parameters. Some people put parameters or speed. I didn't understand the point of the speed. We're going up or down. We could probably put in speed in a future lab. So inside the increase altitude, we need to change the altitude to 1,000 more. So you might just do altitude plus equal 1K. So whatever the value is, I'm a bit confused while I'm talking. Whatever the value is, add 1,000. And what if we do the same thing for decrease altitude? Whatever the value is, decrease it by 1,000. And at the same time, don't forget, we need to give some feedback. Airplane altitude increased by, let's say, 1,000. And I'm probably just going to copy this line. And even better, copy this, put it back here. Decrease by 1,000, and we give the current altitude. Now, let's go inside our cases, add case 4. By the way, if I'm going too fast, go ahead and just pause the video, rewind, do whatever you need to make sure this makes sense. All right, so we're at decrease and we got one last one, exit. We'll come back to this exit in a second. So let's try out our increase and our decrease, and notice that we're just increasing by 1,000 and decreasing by 1,000. And some of you might have spotted some things, and we're going to all spot it in a second. We're gonna run. Now, when we start the engine, well, let's say we don't start the engine and we increase altitude. Hey, the altitude increased. See, but my engine is currently off. So if I say stop engine, you'll notice it says it's already off, but I'm able to increase. See here, I'm not, well, I got lucky and I'm testing it out, our code. But before we normally have to test, we should figure out our logic so this type of error doesn't happen. So we can't just increase our altitude. We need to first have taken off for us to increase our altitude. So if you look, we have one that says, is it grounded? So we're going to say if it's not grounded. So if it's not grounded, what do we want to do? Well, we want to increase the altitude, right? And we know we're not grounded the moment it takes off. The same thing goes with decreasing. If it's not grounded, then we want to decrease our altitude. Cool. And see, the states are managing how our airplane will do an action. The user is still the one that chooses which action to happen, but our airplane is the one that's going to decide what action is going to happen. Okay. So let's go back to here. So we started, we stopped, we take off. What could happen when we increase? Let's go back here. So the motor is on. We're gonna be started as landed. If we land off, we are in the air. Okay. So while we're at the air, so there's some stuff here I didn't point out. While we're at the air, can I stop the engine? No. So one thing is the engine needs to be on for us to be able to stop it. And, okay, and we need to be grounded. If we're not grounded and we stop the engine in the air, well, what's going to happen? Everyone's going to die. This is not a good thing. So we got to make sure that the engine is on and we're grounded for us to turn it off. Now, notice here, I could have also said altitude equals 0. Now, take a second and read altitude if is engine on and altitude equals to 0, and compare it to if engine is on and is also grounded. Which one do you prefer? I believe this one is a bit more English. It's a bit more readable. So the easier reading, the less you have to think. So if the engine is turned on and it's on the ground, then we could turn off the engine. Otherwise, airplane error, engine already off, or now we got to be a bit more specific. This feedback doesn't work if engine is on, but we're not grounded. So here we go a bit more specific. We say is not grounded. And just give me 1 second. And we got an else for the last one. Airplane error. Not grounded. Airplane flying. Cannot stop while flying, let's say. That's a good one. Okay, you write a good message, something that makes sense. Okay, it has to make sense to the user. Feedback's really important. And you're going to see that as we go in the future, bigger exercises, bigger applications, and so forth. So the engine cannot be turned off if we're not grounded. And if we are not grounded, we give this error. And if in the end, the last error would be the engine is just not on. Right? It goes from here. Notice the else's are connected. Right? If, else, else. Now, what else? So if we're in the air, we could increase and we could decrease. While we were talking about grounded, when do we decrease and we are grounded is the moment the altitude is 0. So after all of this, we could say if, in this case, we have to use the altitude variable because we need to see the current value. If the current value is 0, well, now we could say is grounded to true. And we could also let the user know airplane landed successfully, let's say. I can't spell correctly. Make sure you always spell correctly. It's part of life. We have a lot of tools to help us with that. I'm telling you, it changes how people view you. Even though you're not the best speller, you utilize the tools to make sure that you have the best spelling. All right. So if our altitude reaches 0, we set that and we let the user know. If our altitude, let's now go on the increase. There's no point of putting that in decrease or the landing in the increase. If our altitude, and this is a bit interesting, if our altitude is bigger than or equal to 10,000 and under, we don't want to do the same message when we reach 12,000. So we're moving up by 1,000. So we could just say less than or equal to 11,000. Oops. Could have even just said equal to. Then what do we want to do? We want to give a warning. Airplane warning. Altitude in danger zone. And we could even say airplane warning. Max. Let's put in caps to make it that much more important. Max altitude max altitude supported is 11,000. And we could even make it cleaner with a space and so forth, so on. Let me clean off my screen in a second. So here, when it reaches 10,000 to 11,000, we're giving this warning. And the last part, else if, right? Because it's again connected to altitude. We could say altitude 12,000. And again, we could say bigger than or equal to. It doesn't really matter in this case. It will matter as our code gets progressively more complex. But for now, it's fine. So when this happens, what happened? We have to state that the airplane exploded. Airplane exploded. And we could even say boom. All right. Secondly, we need to keep that state that it's exploded. Is exploded to true. And now we need to utilize this exploded in our code. And again, normally what I would do at every step is I would run the code, make sure it makes sense to what I was trying to program. I'm not doing that because otherwise the video is going to be like 40, 50 minutes, especially with me talking. Okay, we could run it just one time here just to make sure that everything's correct. But we got to always test out our code to make sure that it's not going off. So let's see. If I take off while the engine is not started, I should get an error. Good. Can I stop the engine? Again, an error. If I increase. See, here I tried to increase, but there's no feedback. I forgot to do that. Same thing for decrease. Okay. So let's go back. If I want to increase, we said it has to be grounded. Sorry, it has to not be grounded for me to increase. So else. We could, again, specify for each case. So the case where the engine is not on, the case where the is grounded, etc. It's up to you how you do it. I like to give good feedback. So here, else if, let's say if it's grounded, or sorry, let's say if the engine is not on. So is engine not on? Airplane error. Did I already have that? Somewhere, I think it was turning off. Here we go. Engine already off. It's not the same error I wanted. Engine is currently off. Now, else if, what is the other one that's remaining? We could increase our altitude only if we're not grounded. So what if it's grounded? Airplane error. Currently grounded with, currently grounded is fine. And lastly, let's not forget our last error, is it exploded. And again, I could have used else. It's up to you. It's fine. Airplane error. Airplane is exploded. So there is no more airplane. And at the same thing, if I'm doing this for this one, I need to do it for my decrease. Right? Engine is currently off. Airplane is currently grounded. Exploded. Cool. Again, we come back to our main. We run it one more time. See how long the video is currently 40 minutes. Ooh. All right, let's run it quickly. So take off, no can do, stop, no can do. Good. So these are working out fine. So we start the engine. And then let's say we increase. Good. It says currently grounded. We can't increase because we're currently grounded. We could give better feedbacks than this, but this is good enough. Can I stop the engine? Yeah. Can I stop it again? No, it's already off. I start it. I take off. Cool. And then can I stop the engine when I take it off? No. Can I start the engine? See, this engine's already on. We could give a better message such as we're in the air, so forth, so on. Can I increase? Yeah. Can I decrease? Can I decrease again? Good, we're landed. Can I increase now? No. Cool, so it's working the landing part. Let's take off again. Let's go to increasing. We're at 7,000, 8,000, 9,000, 10,000. Airplane warning, altitude in danger zone. Max altitude supported is 11,000. We go one more. We're still getting that warning. If we decrease, we're at 10,000. This is good. On the decrease, we don't get any warning because we're going lower. We could still give the warning. It's up to us. It's our engine. 9,000. All right, let's go back up. This is working out fine. Now at 12,000, we should explode. Boom. Can I increase more? Ew. Look at that. So even though our airplane exploded, we could still increase. What do you think the problem is? Well, if we go back to our increase, these ifs are all connected. And the first question I ask myself if not grounded. So if I'm not grounded, do all of this. Well, I wasn't grounded, but at the same time, my airplane was exploded. So you got to remember what we talked about the if else's is we got to determine what should take precedence over everything else. And in this case, what should take precedence is if it's exploded. If it's exploded, well, nothing else is possible. Actually, we could even put this like this so you can understand that they're connected. It's just, for me, it's not that readable. So here, the first question we ask ourselves, if it's exploded, don't even bother with the other if statements. There's no point. And this is an important thing for us. It's the same thing for decrease. Right? Does that make sense? So remember that these are all connected. So if this one is true, it's not going to even bother looking at the other ones. This is how your computer works. It's a way to optimize and so forth, so on. But this is just the way if statements work. So if they're connected like this, they cannot do it. But the same thing goes with everything else. Let me just go ahead and copy most of this because it's the same thing. Can I take off if it's exploded? No. So if it's exploded, no can do. Can I stop the engine if it's exploded? No. If it's exploded, no can do. Can I start the engine if it's exploded? Nope. If it's exploded, no can do. So again, we're going to go ahead and run this. We're going to start the engine. We're going to take off and we're going to increase. We're at 10,000, 11,000, and here we're at 12,000. Boom. Can I increase again? No. Can I decrease? No. Can I stop engine? No. Anything else? No. Now, some of you, again, exited the application, but this is bad. If you exit the application, you're not giving feedback to the user, and not always we're going to have this console which stays. If they run it as let's say an application, the moment it exits, it closes the application. They're running this console, let's say from an application they ran, and it comes in the console mode. That console normally closes as well. So we got to be careful not to do more than we're asked for. The last thing we need to do is number 6, which is exit. And that's a pretty straightforward. Case 6. we're just going to do a return. Why a return? And that's going to be for our exit, because we're inside of a method, the method called main. So the moment I do return, our method ends and we're moving on. Just to test it out, run our application. We do 6 and our application has finished. Okay, good. We're done. Our application, we checked it. It's pretty good. Let's talk about some optimization that we need to do. One of the optimization, we have this to do over here. This is the rate of change. Notice over here we have 1,000, and over here 1,000, and other places over here 1,000. So there's 3 spots that we had this 1,000. The problem comes down to one day your boss comes to you and says, well, the client doesn't want 1,000 for the rate of change. Now they want it to be 10 or 20 or 30. Well, you got to make sure you go at every one of those spots and change it correctly. If you missed one, your application will crash. If you missed one, you might get a logic error, which is the worst of all errors, right? So there's a lot of issues that could happen by having these so-called magic numbers or magic values, something that you put somewhere randomly. What we tend to do with these is to go at the top and create ourselves some constant values, some final values. So private final int, we don't need to make it static. We could, but we don't need to because we don't need it to exist without airplane. So private final int, and we could say rate, well, let's say altitude, rate of change. And again, because it's a final value, it's all caps with the snake case. And again, this is a bit long, like there's at least 20 characters, but this is easy for us because the moment we want to put that value in there, such as this here, I'm going to remove the to do. We just have to type in A and look at what happens. I only typed in 1 letter and I already got it. And over here, A, oops, I type in 2 letters. And over here, oops. And this helps us clean our code. Because now, if ever our boss tells us to change it to 10, well, okay, we change it over here and it changes everywhere. Changes to 10 million, well, here we go, right? So this is a pretty good, neat way of doing things. Same thing goes with the warnings and the maximum. So we could, again, put some variables so that if we ever need to change it, it's one of the attributes that we change rather than a logic part or something like that. So here, let's say warning altitude, and we're gonna put that to 10,000, right? 11,000, we don't really need to mention. We just gotta mention until it's bigger than 10,000. And then we could also do final int explosion or exploding altitude. Right? So let's go down. We have to change our code again. So this doesn't work because we have 10,000 but not 11. But we know 12,000 we explode. So rather than saying the smaller one first, we'll say this one first. What does that mean? So I'm going to take this and I'm going to make it the beginning of my F. And then the next part, we're going to make it that. So if it's at 12,000, we explode. Right? If it's at 12,000, we explode. Otherwise, we don't need to say there's an upper limit because our 12,000 is already dealing with that. So otherwise, we just say if it's bigger than 10,000, so that's our warning altitude. If it's bigger than or equal to our warning altitude, we're going to give the warning. And if it's exploding, well, it's exploded, it's done. In this way, our code becomes cleaner. Right? So there are some other things we could do, but I don't think I want to do it yet. I just want to keep it clean and neat. So notice here, we've done this as well. So we got 3 final variables. We got 4 attribute variables that keep track of our state. The altitude is the engine on, is grounded, is exploded. And over here, we got some little warnings that says we can make it into a local because if you go look at it, where are we? It was inside the increase. They said local because we're only utilizing it here. But this is not a good one. I like it to keep it here because we don't know where else we want to utilize it. Now, something that's interesting for us to do is because these three are final, we could go ahead and actually showcase them as public. Do I need to do that or not is up to you. Do I need to let people outside have access to know the rate of change? Sure, why not, if they want to utilize it. Should I let them have access to warning? Yeah, why not? They could see what's the warning altitudes, they could make their code a bit better, etc. Right? Should I have given them access to altitude? Of course. So for these four things, we should also give them access to whoever's utilizing our code. So here I'm going to say generate getters, and I'm going to select those four things. So in this case, anyone outside could see my altitude, could see if the engine is on, is grounded, is exploded, and they could also see these three final values. Now you're saying, well, I'm the one utilizing the code and I'm not utilizing those in my main. It doesn't matter. When we built that airplane code, we didn't build it just for this part. We built it so that anyone or any other programmers or any of our colleagues, when they utilize it, they could fully utilize it good and the way they want it, basically, right? And the final thing I would suggest is double check all your states. Make sure that from one state I can't go to something I cannot. Such as, let's say I start the engine, I go up, I take it off, I go a few times high, and then I say stop the engine. Okay. Give some good feedback, make sure everything is dealt with, and we're done. Thanks, guys. I hope you utilize this to do the next lab. Good luck. See you then.